Welcome to another episode of Shop Happenings. It's been a couple months since I've gone out in the shop and shown you what we're up to. So let's take a peek. Run over here to our Grizzly mill drill. We have a countersink bit set up and a jig. What this jig is for putting holes in seat slats. And I don't have one handy here. It looks like we just finished them up, but the seat slat will go into the end here, slide in. This has a stop built in, so as we pull the bit downward, it'll stop at a certain depth, which gives us the correct depth for a countersink for our holes to go in for our seat slats. If I turn around, right here are some sub-assemblies for the backs for our Adirondack chairs. What we've got here, let's stand this up and take a look at it. So here's a sub-assembly for our chair. What you can see here, these are the back slats. We have a back vertical over here. This is the top arc, and if I spin it around, we'll see a bottom arc here and another bottom arc there. So this is a sub-assembly. This is multiple steps to get here. We do some really unique jig fixturing for this so that everything goes together the same. And our goal is to get all our tops of our back slats the same. So we're trying to do these very accurately. We're making 30 of these, so that's one sub-assembly. If I go over here, a rough pile of lumber, you can see we have an arm and leg sub-assembly. This is actually two steps to create this. The curved part is what we call the bottom leg. That's actually where you'll sit, where the seat slats go. The vertical piece is our front leg, and then at the top is our arm. We put these two leg pieces together in a jig and a fixture, and then the arm goes on in a separate fixture. Once that's done, the chairs move on to their next phase. Let's run around the corner and see that. This stack of chairs, is at the next phase where we assemble both the right arm and the left arm and the back verticals. And those three sub-assemblies go together to create the framework for our chair. This is the first time where it actually looks like a chair. Once that's complete, we throw on some brackets. So you'll see there's a front bracket put on here that stabilizes our arm, gives it more rigidity, and then we start putting seat slats on. And you can see this chair has seat slats on it. There's 12 to 13 seat slats per chair. It really depends on how accurate our widths are on our seat slats. It doesn't change how the chair feels or how it sits. It doesn't change the quality of the chair. It just changes the seat slat width. So some of our seat slats might be a little bit wider. We end up with 12 seat slats. Most times we end up with 13. So that's kind of part of our chair project. You come over here, we'll see that we've got a station set up. We were kind of in a hurry yesterday and didn't get cleaned up, but here's our spacer for our seat slats. You see seat slats that are in piles that have been inspected, ready to go. You can see that the countersink hole's already been put in. We're drilling into our bottom legs and then using a long bit to put our screws in. And the reason we use a long bit is we don't want the chuck of the bit or the chuck of the drill to hit the leg because we have to sand that out. Our sanding table is really busy. I'm going to kind of come around the corner here, and we're going to go to one of our Track K3 CNC milling machines. You'll notice that we're covered in white powder. This is a project that one of my friends told me about, gave me one, and I thought it was amazing. I thought I should have students try it. We're trying to make center finders. And these center finders, we're using HDPE plastic, which was donated by Encodima 3D. Don't forget that the Track K3 milling machines were donated by Southwest Industries. And the Track machine tool, what a wonderful company to work with. Their tech support, their technicians, everybody's just absolutely incredible. As we're using all these machines and these donated materials, this is going to have a 45-degree cutout, and I hope this comes out on camera, but here's the student's print for this drawing. You can see that he's going to be making this 45-degree cutout in here. It's 90 degrees, but it's 45 from the face. So that's going to be something that he's working on today. He's done a whole bunch of math, and hopefully we're successful with that today. If I turn around, this is the fixture we just finished up with yesterday. This is how we put our back slats on. So this is how the back slats get put onto the subframe of the back. And we have this really fancy, I'm trying to dig it out here. We have this really fancy jig in this little fixture here that allows us to space out our seat slats. So this kind of spaces out one end, and then this spaces out the other. Works really nice. It gets us real close, then we just kind of eye them up after that. Run over here. Here's a chair that needs fixing. We discovered we had an error with it, so this is going to get fixed today. Not a big error. It doesn't affect it at all. It's just that something our quality control noticed and we need to fix. As you can see, we have our brackets here. And in another video, you can see how we use these. This is a travel card. This part happens to be at step 8. The next step is 9, and there's actually 81 of those here. We keep track of all this with our inventorying system. It works really good for us. That way we don't overmake parts. This cart's full of scrap wood. This scrap wood we used to throw out. And what we're doing with it now is the scrap wood gets run through our power feeder on our table saw. This power feeder works like a straight line rip saw, which is really amazing, and it gives us a gluable edge. So what we're doing is taking that scrap wood, we are ripping out our defects. So notice there's no knots in this entire pile. We glue these up as panels. This pile over here happens to be wood with knots in it. It's all structurally sound, and this again will be glued up in panels, and we'll run that on our CNC router. Our welding area is real busy. Right now we're right in between projects. We just finished up a project which I'm going to show you later. It's a infinitely adjustable system by which we can adjust our shocks in our go-kart. The frame just left here this week to go back to our design room to figure out how we're going to assemble everything. It's nice to have kind of a clean space to do that. We're going to take a look at that now. And as we walk by, you'll see our Grizzly metal lathe. And we're going to kind of run around the corner here and look at our Logan metal lathe. Right now that Logan metal lathe has a part in it that's being bored out and turned to a diameter to make a bushing, and we're making bushings for our go-kart. This happens to be a lower control arm for our go-kart. Our holes that are here, we used pipe. This is just black iron pipe, and when we did this, the pipe was bigger than the bolt we were going to use, so we're actually making bushings to go in here. They're aluminum bushings. We're hoping this works out real well for us. You can see over here there's more of these being made. So here's another lower control arm. And you'll see in here that shiny bushing that we put in. These are working out really good for us. We're making about 3 to 6 thousandths of an inch larger than the hole, and we're just using our arbor press, pressing them in. And so far so good. These are really working out well for us, and my students are learning a lot on how to do that. On this machine, our OKK VM4 donated by Stork, H&E Turbo Blading of Ithaca. We are currently using this fixture, this little jig, which has two socket head cap screws in it and a slot cut in it. And what we're doing is we're putting in leg parts. So these leg parts right here, which are going to get shipped this weekend, actually, we're going to Alabama. We're going to deliver these to the class that invented them. What we're doing with that fixture is we're putting in this hole and this hole. And that hole is actually counterbored. So it's a kind of a 3-operation spot drill counterbore situation for us to use, and that's going to line up with the holes in this part, which we've seen in another video. These make the leg that we're making adjustable. So let's go on and take a look at that in a second too. Over here on our surface plate, which is covered up, you'll see more of our parts that are still being made for those legs. This is a process that we're going through. So these inner pieces are being machined. You can see that it'll slide out and slide in. They're being machined to fit, and then the next process will be what you just looked at. Here we have some vice jaws. Vice jaws, yeah, we're making vice jaws. This is a project we're doing with 3 other schools across the country. It's funded by the Harbor Freight Tools for Schools program, which is really cool. And I'm going to show you that vise right now. So this vise, if I come into my classroom here, that vise was shipped to us by another school. It's actually Steamwood High School in Illinois. They made these bottoms of vices. This is going to go on a mini mill. We don't have a mini mill, but we joined up with them to machine parts. This is an inter school project where we have to design our pieces. So this is the stationary jaw. This is our prototype. So you see this is complete. We've already made this. We've recessed this in. We've machined a slot. We've put this slot in with a ball end mill. This little piece we've already got done as well. This goes on top of that, which then will thread into this piece, which goes underneath the vise. So this is going to be like very similar to like a grinding vise. All our tolerances right. We have a nice, really nice sliding fit here. I'm really pleased with how this is coming out. We're hoping to finish these up in the middle of next week, the whole project. These are being made. They're out on a lathe. I know he's got them all to length, and he's going to start turning on the bosses today, actually. If I run over here, something I don't mention a lot in my videos, this is a part of our applied physics class. This happens to be flow rate in a channel. So we have a little pump here that pumps water out of a bucket. That bucket pumps water through the channel. We calculate volume flow rate and linear flow rate, and it's a bunch of formulas and math that students have to do to get this cross-sectional area of this piece of gutter and then calculate the volume flow rate that that's getting. I really like that. Another lab we're doing right here, this is a conveyor lab, and it's basically rates on a conveyor. We use 1/4-inch washers, and we time how long it takes to get from one end to the other, and then we determine, okay, if we double our mass, what does that do to our productivity? And again, this is just applied physics. It's really awesome class. It's the same class we do the go-karts in. Really enjoyable class for me to teach because it really gets us thinking, and I like to have my students think. I'm just going to kind of show you an overview of the room here. Which is really cool is we do all our CAD CAM stuff in here. This is the place where we do a lot of our thinking, and then the shop we do a lot of our doing. Even though we do a lot of doing in here, this is a lot of more thinking. I hope there's one in here. I don't think anybody did one yesterday. Our 3D printers have been busy. Right now they're off. We shut them off at night if they're not running. Darn, there's not one in here. So we're doing backpack tags, or at least I'm calling it a backpack tag. And it's a tag you can attach to something. It could be a keychain. It could be a keepsake. There's a whole bunch of options for that. It's a really cool project. It's completely designed by students, and it's really enjoyable to watch. I'm going to kind of run around the corner here into our power portal. Yeah, we named it the power portal. You can see up here, power portal. It's where we're designing our go-karts. Our go-kart design is coming along really nice. This is the frame that you saw at the beginning of the year, and we're really moving along. Right now, the lower and upper control arms are off, but we've now got our front end done, our geometry's done, our pedal box is being made. We have the 2 posts right here and here that will be used to put our gas and brake pedals on. We've modded our rack and pinion steering system. We're mocking all this up to figure out where our steering column's going to go. Our seat's been put in place. We've got all our mounts done for the lower control arm. This upper control arm mount is done, just needs to be welded together. We're in the process of building this mount over here. As you can see, we have a bushing made on our plasma cutter to attach our shock so that it doesn't strike our shock mount, which is real exciting. I'm trying to get around the back here. In the back end, we're mocking up where our brakes and our sprocket will go. This just got done yesterday, and we need to get that done so that our rear end that we've all fabricated up will get put together. And this is our motor plate, which we'll put on with a hinge. We're making our own hinge here, which will sit back there so that this can hinge so we can adjust our chain tension. We did that. We retrofitted our number 14 for that. That's this go-kart right here. And we retrofitted that this year. I hope maybe I can show this way down here. You can see if we look right way down in there, you can see there's an adjustment screw. So I can get underneath the cart and see that. Hopefully you can see that. There's a little adjustment screw there that allows us to tighten our chain or tension our chain. And right now this is working out really good for us. We're hoping that this solves our problem with our chain tensioning with this go-kart. We've also adjusted our shocks. Our shocks weren't straight up and down. We got those adjusted correctly, and this go-kart's almost back together. Right now, we're currently tightening up and aligning our brake system, which is back here. So this is really exciting. The other exciting thing we're doing, and this is a really neat project, I just don't know what he did with it. We have an infinitely adjustable shock mount. I may have to go look for that. This was his, so he drew it in CAD. This was his cardboard mock-up. He has 2 pieces machined. We actually started out with this. We decided not to go with that. I'm going to go look for that. I'm going to jump off camera here for a second, go look for that and see if I can find it. So bear with me. Before we do that, a couple more things. We've got our suspension pieces done for our front end. So this is going to allow us to get us caster and camber. We've been working on our 09 over here. Our 09 has a whole bunch of work that we did on the front end that you really can't see. We fixed our steering column. We redid a bunch of bushings, realigned all our panhard bar, all our links, all our tie rods, all that stuff's been done, and we're slowly getting this ready to performance test this spring. Real exciting times for us here. So I'm going to go off camera. I'm going to go look for that mount, and I'll be back. Well, as promised, I'm back. This is our custom mount for an infinitely adjustable shock. We don't know if this is going to work, but we've been working on this design. One student has for, I don't know, 15, 20 weeks off and on. He's been jumping back and forth on projects. So here's our thought. This block, which we've machined out, there's a threaded hole here and a blind threaded hole here. The through hole will allow this block to go inside the carrier. The carrier then will put a threaded rod through here, and that's what this is for. Our threaded rod is going to go down through here, which will then raise and lower our shock mount. When we raise and lower the shock mount, the shock will be attached in a slot here. So you can see there's a hole there, that threaded hole, that blind hole was there. The bolt, I can get this lined up. The bolt here will go through our shock mount. So here's our shock. It'll go through our shock. It'll have to go through a bushing for our clearance, and this will thread into here. And our thought is that now we can just loosen this a half a turn, take the threaded rod that goes through this hole, adjust our shock up and down in the go-kart, and then just snug this back down. And we can make this adjustment real quick. Our goal is to bolt this to the go-kart, so this is going to go on our newest go-kart, and it's going to make our rear shocks infinitely adjustable vertically. That's going to allow us to tune our suspension a little more than what we currently use. And what we currently use are holes that are drilled evenly apart. So as you can see here, I have a hole here, here, here. The shock's in this one. You see two more underneath. These are evenly spaced. What we found is sometimes we're really good here and we're really bad there, but would it be even better here? And that's what this shock mount's going to do for us. And this student has been working on this, like I said, for, gosh, maybe 15 weeks or more, off and on. He's drawn this in CAD. He drew this in CAD. We've machined it, or he's machined it, I shouldn't say we, he's done it. These were cut on our plasma cutter. He's drilled out the holes on a mill. He's now going to cut some threaded rod. He's going to weld a nut on the top and on the bottom. And our jam, so we don't really need a jam nut here, our jam nut is basically this. When the shock gets tightened here, it's going to pull this against the side of this. And our hope here is that this will keep it enough, or give it enough rigidity so that it'll stay where we want it to. And hopefully this will make our adjustments a little better and infinitely adjustable. And I really hope it works. He's put a lot of time into this, and I like the simplicity of the design. It's something he came up with. It was just amazing. So stay tuned for more. I appreciate you taking the time to visit with me today. I know it's been a long time. I hope you enjoy the video. Please let me know what you think, and any input's always helpful, and thanks for watching.